Good morning, Algebra 2. Welcome to Wednesday, April 1st, 2020. Okay. Today, what we're going to be doing, we're going to be matching graphs of parabolas to quadratic equations. Okay, so I'm going to show you a few tricks, but first, let's sit down and get into the norms. As we can see, our norms here. First, we need to see the general form of a quadratic equation, y equals ax squared plus bx plus c, where a, b, and c are coefficients. Okay, critical attributes to remember. When a is positive, the graph is going to have a minimum. Let me give you a little picture. That graph will have a minimum, okay, and goes upward. All right. And when a is negative, the graph is going to have a maximum, and we're also going to call that the vertex, and it's going to go downward. Okay? Also, when a is greater than 0, say for instance it's this is the graph of x squared. Okay, if a is greater than 0, then if a is less than 0, I'm sorry. If a is less than 0, then our new graph will be wider. Okay? And if a is greater than 0, if this is the original graph of y equals x squared, okay, if a is greater than 0, then our graph is going to be narrower okay? All right, that's what that means. When it's narrower, that means it's stretched, and when it's compressed, that means it's going to be wider, okay? All right, okay. To find the y-intercept, we set x equal to 0 and solve, and we're going to have equations where we do that. Okay, this will tell us where our graph crosses the y-axis. Very critical point. And if necessary, to find the x-intercept, I don't think it's going to be necessary today, but if so, if we want to find the x-intercept, we set it y equals 0 and solve. Okay, cheat code, but because we have to teach you how to use the calculator, you can put the equation into the calculator and see what the graph looks like. You can see where it crosses the x-axis, and it's easy to match that way. But we don't want to use the cheat code until we know how to do the math, okay? Because we want to be college ready, and to be college ready, you got to know more than just use a calculator, okay? The axis of symmetry in this lesson will be another very critical point. Pause. What up, Cubby? You good? Thank you, man. Thank you. Okay, people, I'm back. That was somebody at my door, leaving me some oranges. He's my cousin. You might know him. Former Dallas Cowboy, Everson Walls. Yeah, well, he was being nice and leaving some oranges. His mother-in-law lives right down the street. Okay, all right. Sidebar. Now back to the lesson. Okay, as we look here, we left off on cheat code. Oh, we left off on the axis of symmetry. Very important. The axis of symmetry, it always divides our quadratic function. This is our quadratic function. The axis of symmetry is always going to split it right down the middle. Okay, divides it in half. All right. And the vertex, whatever we find out the coordinate of the axis of symmetry is, the vertex is going to be that, comma, y. And we can find out what y is by plugging it back into the equation. And you'll see all this as we go into our lesson today. Okay? For example, all right, before we look at our options, okay, our lesson today says, let's use these attributes to match our equations with our graphs. Before we even look at our graphs, I'm going to show you how to get a rough sketch, okay, so it won't be hard to find our graphs and our options. Okay, so let's look into number 1. Okay. Number 1 gives us the equation y equals negative x squared plus 3. Okay, a is negative. That tells us, oops, we're right here. Okay, here we go. Negative x squared plus 3. Okay, a is negative. That tells us our graph, number 1, is going to be going down some kind of way. Okay? All right, we don't have a b term, so that tells us right there that our graph is still going to be on the x-axis. Oh, this is the easy one. This is simply the graph of x squared flipped and up 3. Okay? So, we take our graph of right here. If we take our graph of x squared if we flip it, it's going to be like this. The negative sign flipped it, and our new graph is going up 3. So the graph that we're looking for looks like this. So as we look at our options, let's see, we don't see that graph on that page. Okay, do we see our graph on this page? Yes, we do. So we see the answer to number 1 is D12. Okay. All right. Okay. Look at number 2 right here. What do we say when when a is greater than 0? It's going to be the graph of x squared, but it's going to be, if it's greater than 0, it's going to be skinnier. Show our graph. We have different options here. Well, it could be this one, or it could be this one. Okay, and let us see. Well, let's plot some points to see, or it could be this one. So we have three options here. So let's see which one it is. Okay, let's plot some critical points. We see that at 1, when x equals 1, all three graphs are different. So let's plug in 1 to our equation. We'll go back to our scratch paper, and we're dealing with the graph this time of y equals, what was it? 2x squared. And we wanted to find out what it would be when x equaled 1. Well, when x equals 1, we solve 2 times 1 squared, the same as 2 times 1, so y equals 2. So we're looking for the graph with the point 1, 2. Okay, so let's go back. Look at our options. And which one had the coordinate 1, 2? Well, this one has the coordinate 1, 2. This one has the coordinate 1, 1. And it was another one we saw. This one has the coordinate 1, 1/2. So the one we're looking for is this one. So for number 2, our answer is D8. Okay. All right, let's move on to number 3. Okay, good. We get our first quadratic equation here. Okay, so we go back to our work page. Okay, I want to get you a new graph. So we'll get a new work page. And our new equation said y, there we go, equals negative 2x squared minus 16x minus 33. Okay, now we want to use our critical attributes. Okay, first thing we see is that it is negative. All right, so we know it's going to be going this way. Okay, all right, because we know it's negative. Okay, now let's find out our axis of symmetry. Okay, our axis of symmetry, because once we find it out, we can find the vertex. Our axis of symmetry equals negative b over 2a. So, since this is b, it would be negative 16 over 2 times a is negative 2. Okay, now we do the math. Negative, negative, that's going to get us a positive 16 over 2 times negative 2, that's negative 4. So our axis of symmetry is going to be at, 4 goes into 16 4 times, it's going to be at negative 4. So we know our equation, our axis of symmetry. Folks, we know our axis of symmetry is going to run through negative 4. Okay, x equals negative 4. Now our vertex, okay, we know it's going upside down. We know our axis of symmetry is at x equals negative 4. Now we plug that into our original equation. So y equals -2 minus 16. We put parentheses wherever x is going to be, minus 33, because we said x equals -4. Keep in mind, our vertex is going to be -4, comma, whatever we find out y is. So, -4 squared is 16. 16 times -2 is -32. 16 times -4 is +64 and minus 33. Okay. -33 and -32 and -33 is -65 plus 64 will equal -1. So y equals -1. So our vertex is going to be -4, -1. So we flip over. Now we know our vertex is going to be right here. Okay, we know our graph will be going upward. Okay, and if we want to know our y-intercept, one more critical point, to find the y-intercept, we set x equal to 0. So in our original equation, if we set x equal to 0 here, that cancels out. We set x equal to 0 here, that cancels out. So we're left with y equals -33. So our y-intercept is, there we go, I'm sorry. Our y-intercept is 0, -33. Okay, so we have critical points here. We know our y-intercept is going to be way off the graph. Okay, we know it's going to be going down, and since we know our y-intercept is way off the graph, we know we won't touch it for a long time. So we know it'll be going down like this, and it'll be going down like this. Okay, and we know our vertex. Okay, so now, let's take this and go back to look at our options. First of all, we're looking for the graph that's going upside down. Okay, we have a D4. Sorry, we put these all on the same page. Okay. We have D4, in which we have a vertex of -4, -1. So let's check that out. We might not have to go any further. Okay. We had D12, we already used it, but to check it anyway, different vertex. No vertex of -4, -1 here. No vertex of -4, 1 here. No vertex of -4, 1 here. This vertex is 0, 0. This vertex is 1, 3. This vertex is 0, -3. So the only one, we don't have to go any further. The only one that matches, ding, 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 here's our winner, D4. Okay, so now, I'm going to do one more, and then we get to see you practice. Okay? All right. So, different set of scratch paper. Okay, and class, if you have access to a copy machine, I can send you an electronic copy of my graph paper, and you can email me at richard.insley@texas.org. Okay? And I can send you an electronic copy of the graph paper that you can keep on your desktop. Okay? All right, so let's look at the next equation. Next equation says y equals 4x squared minus 8x plus 4. Okay, let's find some critical points here. Let's find some critical attributes. First of all, we know it's going, this is positive, so we know it's going to be going up. Okay? All right, now let's find our axis of symmetry. Negative b over 4a, which will be over 2l, sorry. Okay, negative, notice we circle b and its sign, negative 8 over 2 times a, which was 4. So negative, negative, that's going to be positive 8 over 4 times 2, that's 8. So we see that our axis of symmetry is going to be at x equals 1. So we can flip over and we can draw our axis of symmetry at x equals 1. And we can draw our axis of symmetry. Okay? Now all we need to do is find the vertex. We know it's going up, but we need to find the vertex. Okay, and our vertex is going to be 1 comma, whatever we find out what y is. So when we plug 1 back into our equation, remember, make your parentheses for x, so we can substitute back in. Okay, and we said x was 1 this time. So 1 squared is 1 times 4 is 4. Minus 8 times 1. Okay, plus 4. All right, so 4 and 4 is 8 minus 8. Easy one, y equals 0. So we know now that our vertex is at 1, 0. So we flip over, and we know our vertex is right here at 1, 0. We know that it's going up. So let's check. all our graphs going up before we even make a picture, before we even plug in to see what the y-intercept is. Let's check, okay? But just to be sure, well, let's just check right here. We may not need to, well, to find out what the y-intercept is, we flip back over, and once again, we set x equal to 0, so that's going to cancel, that's going to cancel, and our y-intercept is 0, 4. We can go back to our graph. We know that our graph is going to run through 0, 4 here. Since this is the axis of symmetry, on the other side of it, it's going to run through there. So our graph is going to kind of look like, it's going to kind of look like that. Okay, so let's look at our pictures and match our graph. Okay, first of all, we look for the vertex, and we know that it's going to be 0, 1. So that's not it, that's not it, that's not it, that's not it, that's not it. That's on 0, but that's 0, 3. Okay, and that's no good, so it's not on this page. So on this page, we got two graphs that are going up. Well, that's 0, 1. We know it's not that one. And this is the only one. And as we can see, it has our y-intercept labeled also. Ding, 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 ding. There's the winner. Okay. So now it's time for you to do a couple. And then, so this was our answer here is D, 13. Now it's time for you to do a couple. Okay, so for numbers 5 and number 6. Oh, let me get this back in focus for you. Okay. Numbers 5 and number 6. Okay. I want you to find critical points. And when I say critical points, I want you to determine whether it's going up or down. Okay. And A will tell you that. The sign of A will tell you that. Okay. Then I want you to find the axis of symmetry. Okay. And we know that equation is x equals negative b over 2a. All right. And once you find the axis of symmetry, I want you to find the vertex, which is whatever you come up with for x in the axis of symmetry. Plug it back in, and that will give you y. And I also want you to find the y-intercept. Okay, which in a quadratic equation, the y-intercept is always going to be the c term. All right, so we have 1, 2, 3, 4 things to do, and you have, hey, come back, light. All right. Okay, you have your assignment, and the lights went out just in time. You have approximately 3 minutes, and I'll be back. see, technical difficulties are over. But you still have a couple of minutes. Actually, I will give you about 5, okay, to finish the 2 problems. And then I will be back. Okay, peeps, you've had enough time to do the first one, so let's check the first one to make sure you're on the right track. The equation was y equals negative 2x squared plus 4x plus 1. So the first thing you should have determined based on the 4 things I wanted from you, that this negative sign means it's going down. Okay, going down. All right, the next thing you should have determined is the axis of symmetry, where you saw x equals negative b over 2a, where b is negative 4, so that's negative 4 over 2 times a is negative 2. Okay, so we get negative 4 over negative 4, which is 1. Okay, so you automatically know now that our axis of symmetry is at x equals 1. So once again, we're here, and we know our graph is going down. We also know now we can find out the vertex, okay? And the vertex is whatever we had for x, which was 1, and we need to find y. And how do we do it? By plugging 1 back into our original equation, so negative 2. Remember your parentheses. Okay, plug in 1. So 1 squared is 1 times negative 2, that's negative 2, plus 4, plus 1, negative 2, plus 5, so y equals 3. So our vertex now we know is at 1, 3. Okay, so we go back over. And we go up to 1, 3, and we go over 1, up 3, and we mark our vertex. And we know it's going down. So all we need now is one more thing. Where does it cross the y-axis? Okay, so our y-intercept, we said was always going to be the C term. And there we go. So our y-intercept is 0, 1. Okay, so we know now our y-intercept is here. And since this is the axis of symmetry, there should be another point just the other side of it. Same distance. And now we know what our graph should look like. And we go. And we look at our options. Okay, upside down. That doesn't qualify. Wrong vertex. Upside down over here, we're looking for a vertex of 1, 3. And look, there's only one vertex that had 1, 3. And there's our y-intercept. Okay? All right. And last problem. Okay, I will give you 2 minutes to finish your last problem before I turn you loose on your homework, which is your exit ticket. Guess who's back, peeps? It's me again. And I'm not even the boogeyman. It's Coach E. Alright, so I hope you saw that this was positive. So we know our graph is going upward. Okay? I hope you said the axis of symmetry equals, well, it is x equals negative b over 2a, which is, this is b is positive 6 and a is 1, so that's negative 6 over 2 times 1, which is negative 6 over 2, which is negative 3. So our axis of symmetry, if you drew your graph, your axis of symmetry is running along x equals -3. Okay. Then we go back over. We find our axis of symmetry. Now we want to find our vertex. Find your vertex. you should have plugged in -3 into your equation. So our equation is x squared plus 6, 6 times x and plus 9. And we see that x is -3, -3. Okay, so -3 squared is 9. 6 times -3 is -18, and plus 9. 9 plus 9 is 18, minus 18 equals 0. So our vertex is x is -3, and y is 0. So we flip back over, and we see that our vertex should be -3, 0. And we said our graph is going upward. And if we just want to be accurate, our y-intercept is going to be 9. Ooh, not that one. Yes, 9. So our y-intercept is going to be up here. So our graph should look like, and if it's 3 over to the axis of symmetry, it's going to be 3 to the other side of the axis of symmetry. So our graph should look something like that. And when we go to our paper, looking at our graphs to go up. Okay, first thing we look for is the vertex of -3, 0. Okay, we have winner, winner, chicken dinner so far. Okay. So far we have D1 with that vertex. And it also has a y-intercept of 9. So far that looks like the winner. But let's check the other ones. Vertex here is 0, 0. Vertex here is 0, -3. Vertex here is 1, 0. So the only one that matched was D1. So our answer here would be D1. Okay. All right. So, and our other one, we said our answer was going back, our answer here was D16. Okay. All right. So now, I don't think we need to go any further with practice. But if you want to continue practicing, you can practice these on your own. Okay. And let's not forget to do your exit ticket. But before we leave, let's remember the things we did today to determine whether, well, our general equation was y equals ax squared plus bx plus c. Okay, to determine whether it's going up or down, we see whether x is positive or negative. If it's positive, our graph is going to be going up. If it's negative, our graph is going to be going down. Okay, then the axis of symmetry, to determine where our graph is split in half. The axis of symmetry, we use the equation -b over 2a. Then this equation will be in the form of x equals something, which goes right here. And to find our vertex, we'll plug that back into our original equation and solve for y. And to find the y-intercept, we simply look to see what c is. Okay? So, we've learned how to match quadratic equations to graphs using critical attributes. And my peeps, I hope you've had fun today. That's 2 lessons down this week, and we have 1 more to go. So, have a good evening. Do your exit ticket. Submit it to me in my box. Or submit it to me, and have a good evening. All right, see you tomorrow.